Here is our fourth lecture quiz question. The moon does not have a magnetic field. This means A, there are no magnetic metals. A, there are no magnetic metals on the moon. B, there is no conductive liquid in the moon. C, the moon does not rotate fast enough. Go ahead and think about it and we'll discuss in just a bit. So why doesn't the moon have a magnetic field? Well, there are magnetic metals in the moon. We've been talking about iron quite a lot. And the moon does actually rotate fast enough. It does take a full month for it to rotate once on its axis, but that is fast enough that it could generate a magnetic field. So the answer is B. There's no conductive liquid in the moon. Because the moon is small, it has lost most of its internal heat. Because it doesn't have the internal heat, that means that it does not have the energy required to drive geologic systems, and it has cooled off so that it is pretty well solid all the way through. Because it is solid all the way through, there are no liquid metals on the inside, and therefore no magnetic field. And now our fifth lecture quiz question. How do we know the structure of the interior of the Earth? A, through seismic waves refracting. B, through deep Earth drilling. C, by looking at meteorites. Or D, through density considerations. Go ahead and think about it and we'll discuss in just a bit. So the idea is that we look for where the seismic waves hit on the surface of the Earth, and then, where there are gaps, that tells us about how the waves have refracted through the Earth, indicating that there are distinct layers. Well, during the Apollo moon landings, the astronauts placed several seismographs as well as magnetometers. This has allowed us to figure out the structure of the interior of the moon. Now, the moon has no magnetic field, but it has evidence that it used to have a magnetic field in the past. Specifically, we get this from ancient moon rocks. Well, if the moon had a magnetic field at one point, that means that it must have also had a liquid metal interior at one point to generate the magnetic field. So that suggests that the moon did differentiate. The seismographs have revealed that the moon has a very thick lithosphere and asthenosphere. The lithosphere is the part of the moon that is rigid. Asthenosphere is solid but plastic. Remember, plastic means moldable. Solid but moldable. Now, the moon does not have any tectonics. Remember, it has lost most of its internal heat, and it's the internal heat that drives geology. So the moon has been basically geologically dead for all of its existence. What this means is there are no tectonics, and therefore there should be no moonquakes. However, because of the elliptical orbit of the moon, this can generate moonquakes. As the moon swings closer to the Earth, it feels a greater gravitational pull, which increases the tidal force, the stretching because of the difference of gravity from one side to the other. Then when it swings away from the Earth, the tidal force decreases and the moon relaxes. So every orbit, it stretches a bit and then relaxes, which can generate moonquakes. Another source of moonquakes are meteorite impacts. During the Apollo missions, we actually intentionally crashed some of the used-up fuel tanks into the moon to create some seismic waves, similar to what's happening with meteorites now. If you remember back to when we were talking about the formation of the solar system, one of the mysteries that we still had to explain is where did our moon come from? That was one of our weird exceptions that we have to explain. One of the first proposed ideas for how the moon formed noticed that the moon was slipping away, and because the moon was slipping away, it actually caused the Earth to rotate slower. This is caused by a conservation of angular momentum. The moon slipping away is actually stealing angular momentum from the Earth. So the moon slips a little bit farther, and the Earth slows down. So the idea is, if we go far enough back into the past, then not only did the moon have to be closer, the Earth had to be spinning faster. We do see this in the geologic record. There is evidence that the Earth spun much faster in the past. So the idea is that very early on, the Earth was rotating so fast that the moon actually got thrown off like a lump of mud on a fast-moving tire. And since that time, the moon has slowly been pulling away from the Earth, causing the Earth to rotate more slowly. I really like this idea, but unfortunately we know it doesn't work. Specifically, if the moon had formed in this way, it shouldn't have a lot of iron in it, and yet we know that it does have an iron core. Another idea suggests that the moon was a very large asteroid that happened to get captured by the Earth's gravity. Again, this is a really fun idea, but it doesn't work. As we look at moon rock, it is far too similar to the Earth rock for it to have formed somewhere else in the solar system and then be captured by the Earth's gravity. Today, all of the evidence we have points to the moon being formed due to a giant impact, that the Earth got hit by a protoplanet that's about the size of current-day Mars. As this impactor came in, it crashed into the Earth so hard that debris of both the impactor and the Earth got ejected into space. This material then eventually re-accreted into the moon that we have today. This is our best scenario, and it matches all of our current available evidence. Now, there are variations as to exactly what happened. I've heard some things suggest that instead of a single impactor, it was a whole bunch of smaller impacts. I've seen other things to say that the impactor was much larger. Instead of the size of Mars, it was actually the size of present-day Earth. But pretty much all of these agree that the moon was formed due to a giant impact on the Earth.